Next, I want to look at a method of extracting date and time data for the ETL process. The idea is that you'll have a date table in the usually called dim dates and a time table usually called dim time, and you want to fill up those tables. But you need to generate that data because most of the time you can't pull it just from someplace. What we've been doing so far, we've been pulling existing data and then transforming it. Now we're actually going to generate it. Well, we'll look at a couple different code samples, one for date and one for time, and usually you want to keep those separate because if you put them in one table, you end up with millions of rows. But anyway, let's get on to looking at these code samples. Here's an example from your book. It's going through and setting up some dates as a start date and an end date. Now the dates are pretty old, and that's because the data we're dealing with is pretty old. So we're going to go from 1990 to 1995. And we're going to declare a date and process variable, and then set that date and process to the start date, 1990. Now this code can be complex, especially if you're not a SQL programmer. If it is, just kind of follow the thought process. The thought process is most important right now. You can always look this code up or borrow mine and use it. I've got a while loop here. So while it's true that the date and process is less than the end date, in other words, less than the first day of 1995, I want you to keep looping. And I begin by inserting into my dim dates table the date, the name, date name, the month name, quarter name, year, and year name. And I'll get this date and process, which at first will be the first day of 1990. Extracting that out, the month with the date name function, month, and year function, and a cast to convert it so that it's textual data instead of integer data. Year and month pull out integer data. Then, as it finishes pulling that and pulling it out of, calculating it and then putting it into the dim dates table with the insert, I will bump it up by 1 day and do it again. And I'll keep doing that until eventually I'll hit the last day of 1994, and that will be still later than the first day of 1995. And then I'll run out of dates and the loop will stop. So with that code, I'd be able to generate this data pretty quickly. It'll run for a little bit. Actually, I think it ran already. And I'll just check to see what kind of data we have in there. Now you may see that I've got this data filled up, and I've also gone ahead and inserted some static data. Let's see, where did I do that here? Let's have done it at an earlier point in time. I don't see the code right now, but I've just inserted some static data into the table to represent days that are unknown, or perhaps we don't believe that the values are correct. They're corrupt. I'll talk a little bit more about that when we get to dealing with nulls, which is next video coming up. But for right now, this actually has generated the date data for us. Once it's done, I don't need to run it again and again and again. So it could be part of the ETL process, or it could be part of just the initial creation of the data warehouse database. It would really be up to you. We're going to go ahead and put it in to our ETL process in our class and have it regenerate over and over again, which is not very efficient, but it will show you how you can deal with complex SQL code. I want to show another example that's not in your book. This has to do with dealing with time. So I'm going to use the getDate function to get today's current date and time. I'll pull out the hour, minute, and second with date part. And you can see that it is currently 4 o'clock, 48 minutes after the hour, and 6 seconds. I'll go ahead and create a variable. I'll call it time. I'll set it for the year 2000, first day. Let's say 5 seconds. And I'll use date part to pull out that value. like so. Now I could go ahead and create a table in the TempDB, and then once I created that table, or whatever database I want, I could then go through and do pretty much the same thing we do with the date data. I make a start time, I make an end time. Notice that the days are 1 day different, so, and then I have minutes, hours, minutes, and seconds. And I just go through and extract out the hour, the minute, the second, and then bump it up by 1 second and do it again. Now this is one of the slower ways of doing it because the functions have to fire repeatedly. There are some trickier ways of doing it. You can search the internet for generating a time dimension table with SQL, and you'll find some cool examples that they run a lot faster. But you can see that two things here. First of all, that it's working. 1, 2, 3. The second thing is that there are a lot of rows if you take it down just to seconds. So for seconds, minutes, and hours, there's a lot of rows in a table. 776 rows, and that's just for 1 day. You'd multiply that by 365 for each year, and then you'd end up multiplying it for however many years you want it. But you can see here, it looks like I may have a bug in my program. You get the hours and minutes and seconds. Did you give up? No, I think it's just that so small that it's just not showing at all. I probably ran out of buffer, completed with errors. Yeah, I think we ran out of space for that to hold it in memory for the results. Again, it's a lot of processing. But that's how you could actually extract out time data. And again, there are other more economical ways of doing this, but it still gets the point across of how you could generate time data. Okay, next on the list, I want to talk about handling nulls. So I will see you in that video.